All right, the first thing I'm going to do for this question, it says, how are the three elements above organized on the periodic table? So on my periodic table that I have, I want to either circle or highlight or whatever. And they made it real easy for you because they gave you the atomic numbers. So it makes it easier to find them on the periodic table. So you have number 41, and I have number 27, and I have number 21. Now, if I look at the periodic table, I notice that SC and CO are in the same period, but that's about all I see so far that they have in common. So it says niobium and cobalt are in the same group. Well, none of them were in the same group when I'm looking at my periodic table, so I can cross that one off. Cobalt and scandium are in the same period. So remember where I said I already looked, and these two were in the same period, so that's a possibility. Cobalt and scandium are in the same group. Well, they are not, because groups go up and down and periods go side to side, so this one is not true. And then it says niobium and cobalt are in the same period. Well, the only two that were in the same period were the SC and the CO, so that's not true. So I know my answer is this one. All right, next one. It says refer to the periodic table above. A student is asked to identify an element that is non-reactive gas and does not conduct electricity. Within which group on the periodic table would this element most likely be located? This is super easy. The noble gases, group 18, are the ones that are non-reactive. So I don't even have to look at any others. Should have been group 18. This last group is the one that have the 8 is great. Their rings are all full, so I don't need to go any further with that. Which property determines the identity of mercury? Okay, so what I would do with mercury, and mercury is Hg. So I'm going to find that on the periodic table, and I'm going to circle it. It has an atomic number of 80. I'm going to do Ape Man for mercury. You should know how to do Ape Man because we did it 1,000 times in class. Okay, so I know my atomic number is 80. So that means my protons are 80. My electrons are 80. So those are all the same number. So my rounded atomic mass is 200.5. So if it's 5 or more, let it soar. 4 or less, let it rest. I think that's what y'all taught me. So if I'm at 200.5, that's going to give me 201. And I already know, I'm just taking this A from up here, putting it down here. So you have a calculator up here. Use it so you don't make a silly mistake. But 201 minus 80 will give you 121. All right, so let's go through and says an atom of mercury has 120 neutrons. Well, that's not true. Mercury is liquid at room temperature and normal pressure. That is true, but that doesn't determine the identity of an element because I'm looking for the identity of the element. An atom of mercury has 80 protons. This is correct. And remember, my protons always tell me an element's identity. Mercury is located in group 12. Well, that's true, but again, it doesn't determine its identity, and that's really what I'm looking for. So my answer should be an atom of mercury has 80 protons. All right. Next one. This question has two parts. First, answer part A, then part B. Use the periodic table to answer the question. How many valence electrons are found in bismuth? So I'm looking for Bi. Here it is. I know that the group tells me the number of valence electrons. So if I travel up, and I'm going to look at my periodic table that I have in front of me because this one doesn't have the group numbers. It is in group 15, but groups 15 through 18, or sorry, 13 through 18, I have to subtract 10 or look at the one with the A under it. So I know that it has 5 valence electrons. So I'm going to click 5. See, they try to trick you with 15 because they know you're going to go look at the group. And then which best supports your answer? It says the group number next to the A tells you the number of valence electrons. Well, I literally just said that, so that's true. The atomic number tells you the number of valence electrons. That's not true. It tells you the number of electrons, but not valence electrons. And the period the element's in tells you the number of valence electrons. Nope. That tells you how many energy levels. In order to perform an experiment, a chemist needed an element that has similar properties to potassium but has a lower atomic mass. What element should the chemist select for the experiment? Anything in the same group is going to have similar properties. So if I find potassium on the periodic table, it's in group 1. So I'm looking for something in group 1 that has a lower atomic mass. So I have sodium, lithium, and hydrogen that all have a lower atomic mass. So the only one of those that's an answer choice is sodium. Use the periodic table to answer the following question. What is the total number of protons, neutrons, and electrons that can be found in beryllium with a mass number of 9? So I want to do 8-man for this. That'll make it so much easier. So it already gave me that my mass number is 9. So I'm going to put 9 here. And I'm going to go to the periodic table and find beryllium and see that it has an atomic number of 4. I'm going to have to get a different color here. So my protons are 4. My electrons are 4. I'm going to take this A down here. So that's going to be 4. So I'm going to do 9 minus 4, which is 5. Again, you have a calculator. If you need it, use it. So it wants to know the total number of protons, neutrons, and electrons. So I'm going to add protons is 4 plus neutrons is 5 plus electrons is 4. So if I go 4 plus 5 plus 4, that would give me 13. So that's what I should put in this box. Again, if you do 8-man, then you'll get the correct answer. All right, next. Use the periodic table to answer the following question. Which element has 3 energy levels? Well, when we drew our Bohr models, when we were looking for those big circles to go around, we were always looking at the period. So it says if it has 3 energy levels, then it's going to be in period 3. So 1, 2, 3, this one, and this one. Those should have been your answers. Select the element on the periodic table that are highly reactive. We talked about this over and over and over again. If they are highly reactive, they are in group 1 or they are in group 17. So if I look up here, I have one that's in group 1 and I have one that's in group 17. So it should have been hydrogen and bromine. Which of the atoms below has the lowest mass number? All I have to do is count how many are in the nucleus. So I've got 1, 2, 3, 4, 5, 6 here. I've got, whoops, 1, 2, 3, 4, 5, 6, 7. So it's not that one. One, 2, 3, 4, 5, 6, 7. Not that one. 1, 2, 3, 4, 5, 6, 7. Not that one. So the lowest atomic mass is the one with the least amount in the center. So it should have been this one. All right, sulfur is yellow, powdery substance. It's a poor conductor when made into a compound and can sometimes smell burned. Which of the following statements correctly describes atoms? Okay, so I want to do an 8-man for sulfur. All right, sulfur is number 16. Its atomic number is 16. So its protons are 16. Its electrons are 16. It has a mass number of 32.0. So that means it's just 32. Carry down my A. So now I'm going to do 32 minus 16, which is just 16. Again, you have a calculator up here if you need it. So let's look at our answer choices. Sulfur atoms have 16 protons. Well, that's true. Sulfur atoms have 6 valence electrons. Well, sulfur is in group 16, so it would have 6 valence electrons. Sulfur has 16 valence electrons? No. Sulfur atoms have 17 electrons? No. So these are my 2 correct answers. All right, refer to the image above. Which of these is not found in the nucleus of an atom? Well, this is the atomic mass. The nucleus makes up the atomic mass, so that is found, and we're looking for not. Electrons are found outside the nucleus, so that's not in there. Neutrons are in the nucleus, and protons are in the nucleus. So my answer should have been electrons. Those are not found in the nucleus. What number of valence electrons are in an element with 17 protons? Well, there's 2 ways to do this. You can either draw a Bohr model for it, or you can look at the periodic table, and if I have the number of protons, then it's going to tell me the atomic number, because remember, ape is the same. So that tells me that this is chlorine. So looking at chlorine, it's in group 17. So I just subtract 10, or I look at the little number with the A next to it. So my answer should be 7. Which of the following is the atomic number of the atom represented with the above graphic? Well, protons always tells me the atomic number. So, because remember, ape is the same, APE. If I have 16 protons, then I have 16 electrons, and my atomic number is 16. So the answer should have been 16. All right, the following question has 2 parts. Answer part A, then B. A group of scientists were studying the reactivity. So automatically, I know if they are talking about reactivity, that we are talking about valence electrons. So of elements, and notice some of the elements were highly reactive while others were chemically stable. Which elements listed below have the least chemical reactivity? So again, group 18, anything in group 18. These are the noble gases and they are not reactive. 8 is great, they are happy. So sodium is in group 1, so that is very reactive. Neon is in 18. Oxygen is in 16. And bromine is in, where is it? I know I'm missing it. 17. So that's very reactive too. So my answer to that one should have been neon. It was also your warm-up question. So hopefully you didn't miss that. All right, which basically supports your answer. The greater the number of protons, no, we talked about it. We're talking about valence electrons here. The atoms of elements in group 18 have complete outer shells. That is true. Only elements that are considered metals are highly reactive. No. Elements in group 1 have, no, they're highly reactive, just like group 17. Which of the following statements accurately describes valence electrons? Select 2. Valence electrons can be used to identify the atom. No, those are protons. Valence electrons determine the reactivity. Yes. The number of valence electrons is equal to the group number of the element. Yes, kind of. Yeah. The number of valence electrons is equal to the atomic number. No. Valence electrons are located in the nucleus. No. So those are definite no's. We know that, yes, they tell you the group number, but 13 through 18, we have to subtract 10 or look for the number with the A next to it. So these are our best answer choices here. Which of the following statements accurately compares elements of oxygen and selenium? So again, first thing I'm going to do is find them on my periodic table and highlight them. Oxygen is in group 16. It's got an atomic number of 8. And selenium, I'm looking for it, is also in group 16 and has an atomic number of 34. So they're in the same group. Atoms of oxygen and selenium have equal number of energy levels. No, because they are not in the same period. They are in the same group. Atoms of oxygen and selenium have equal numbers of valence electrons. True. Atoms of oxygen and selenium have equal number of protons. Nope, their atomic numbers are different. Atoms of oxygen have more protons in their nucleus than selenium. No, oxygen only has 8 and selenium has 34. So atoms of oxygen and selenium have similar chemical reactivity. Yes, if they have the same number of valence electrons, if they're in the same group, they are going to have very similar chemical reactivity. So those are my 2 correct answer choices. The image below are models of atoms for different elements. Which of the following statements accurately describes the elements presented in these 2 models? Okay, so here are my Bohr models. Remember, my protons tell me the atomic number and the identity. So let's just try to identify them first. So I've got 1, 2, 3, 4, 5, 6. So that means this is carbon. And it has an atomic number of 6. And it is found in group 14. So I'm going to put a star next to that on my periodic table. And then this one has 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is fluorine. It has an atomic number of 9, and it is in group 17. So they're not in the same group, but they are in the same period. Both of them have 2 energy shells, so they're both in period 2. So let's look at our answer choices. Element 1 is beryllium. Nope. Element 1 is carbon. Yes. Element 2 is fluorine. Yes. So that's an answer choice right there. Element 1 and element 2 are in the same period on the periodic table. Yes. Element 1 and element 2 are in the same group. Nope. Element 1 and element 2 have similar chemical reactivity. No, they're not in the same group. So these are my two best answer choices. So hopefully you took some notes, you have learned from your mistakes, and you are ready to go ahead and do a retest. Make sure that you schedule it with your teacher during an advisory time for you to come do a retest. Also, you can come to tutoring either before school or during advisory also if you need extra help with